Today's lesson is on special right triangles. And what is a special right triangle? Well, a special right triangle is any right triangle whose angle measures are 45, 45, 90 or 30, 60, 90. Those are our special right triangles. Okay, so we have a theorem for the 45, 45, 90 triangle, and it says in a 45, 45, 90 triangle, both legs are congruent and the hypotenuse is the square root of 2 times as long as each leg. So if you look at your diagram here, these are my two congruent legs. It's a 45, 45, 90, right? Since the base angles are congruent, I know by the converse of the base angles theorem that these two sides would be congruent. So if we label both of them as x, then we know that the hypotenuse will always be the square root of 2 times whatever that leg length is. All right, for a 30, 60, 90 triangle, we know the hypotenuse is twice the length of the shorter leg, and the longer leg is the square root of 3 times the length of the shorter leg. So if you have a 30, 60, 90 triangle, the first thing you want to do is label your sides as short or shorter, longer, and then of course the other one is the hypotenuse. How do we know which one's shorter or longer? Oh, we learned this in the last unit, right? Since 30 degrees is smaller than 60 degrees, we know that the leg across from the 30-degree angle is always going to be the shorter leg. All right, so let's see how we use these theorems. We don't have to go around using the Pythagorean theorem now. This saves us a lot of time. So you really have to remember these theorems. Find the values of the missing lengths. Okay, well here's my 45, 45, 90 triangle. So what did I just learn? I learned that the hypotenuse length is going to be the square root of 2 times the leg length. So that's just going to be 7 times the square root of 2. Do not want you to type that into your calculator and give me a decimal. We're going to be working a lot with radicals in this unit, and we're going to always leave our answers as simplified radicals. All right, now we have a 30, 60, 90 triangle, so I know this is the short side, this is the longer side, and then of course the hypotenuse. So what do I have here? I have S. Okay, so S is the short side. If I know that the long side, so 9, is the square root of 3 times the shorter side, right? Isn't that what I know? So if I want to find what S is, I have to divide 9 by the square root of 3. And what do we know about that? We know we can't leave a radical in the denominator, so we have to rationalize that. Multiply top and bottom by the square root of 3. We get 9 times the square root of 3 over 3. And of course the 9 and the 3 will cancel. So S is going to be 3 times the square root of 3. All right, and what did we learn in the theorem about the hypotenuse? The hypotenuse is 2 times the length of the shorter leg. So T is going to be 2 times 3 square root of 3, and that's going to be 6 times the square root of 3. So there are my leg lengths. If you don't believe it, then you can check it out using the Pythagorean theorem, but you will find that these two theorems for special right triangles always hold true. All right, so that's really it for special right triangles. We just have a few more examples on the next page. So as I usually do, I'll probably do 1 or 2 of them, and then I'll let you do 1 or 2. So let's look at this one together. All right, I know that these two will be congruent, so I know that x equals 4 right off the bat. What is y? Well, it's 4 times the square root of 2. Pretty easy, huh? How about this one? All right, which one is my shorter leg? A. A is my short leg, and this is my long leg. So what do I know? I know that the long leg, 10 times the square root of 3, is the square root of 3 times the short leg. So if I divide 10 times the square root of 3 by the square root of 3, I just get 10, and that's how long our shorter leg is. All right, and of course the hypotenuse is 2 times the short leg, so B is going to be 2 times 10, which is 20. Pretty easy, huh? This is a nice little lesson. Nothing too difficult here. All right, let's see what we have here. Well, since I know that both of these are right triangles, I'm going to focus on this one triangle. This is a rectangle, right? Well, I can focus on the top. It doesn't really matter. This is going to be 15. This will be M. And so let's see. I know this will be 30 degrees because these two angles here have to be complementary. So what do I have? I have the short side. The short side is given to me. So I know that M, the long side, is just going to be 15 times the square root of 3. And therefore N is going to be 2 times that, which will be, I'm sorry, N is going to be 2 times the short leg, which is 15, so 2 times 15 is 30. Almost messed up there, but yep. So M is the longer leg. It is the square root of 3 times 15. The hypotenuse is 2 times the short leg, so 2 times 15 is 30. All right. Why don't you pause here and you try to work this problem, come back and I'll have the solution up for you. Okay, so we know the window is a square because they told us that, and we're to find the area. So how do we find the area of a square? Area of a square is the side length squared. So all we got to do is find the length of one of these sides here. All right, well, if this is a square, I know this is 90 degrees, and since I know that all the sides of the square are congruent, then I know that these are both going to be the same, which means that these both have to be 45 degrees. Now I got myself a 45, 45, 90 triangle. I know the hypotenuse of it, so I know the leg length of this triangle that I've outlined here is the hypotenuse length divided by the square root of 2. I get 36 inches, and then of course I want to square that to get the area, and I come up with 1296 square inches. Okay, now this is a short lesson, less than 8 minutes, so you really need to write your summary, make your flashcards, and then I would strongly encourage you to get your work packet out and work some practice problems. The more of these you do, the more naturally they'll come to you, and you need to really be strong with your special right triangle rules.